Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Aiman Najmi, and today I will be presenting about my final year project 1. So the title given mobile robot navigation in indoor environment using Kinect sensor, and my supervisor is Dr. Rostam Saleh. Okay. For the presentation outline, we have introduction, literature review, methodology, conclusion, and also reference. Inside introduction, we have problem statement, objective, expected outcome. In methodology, you have methodology procedure, project Gantt chart, and also project cost. Okay, introduction. So mobile robot can be navigated either indoor or outdoor environment, but there are several problems that mobile robot navigation facing, especially in localization. Also, Kinect sensor is a sensor that can detect its environment in 3D due to the presence of depth camera, infrared camera, and also projector, infrared projector. So actually this project is all about navigating a mobile robot using a Kinect sensor in indoor environment. So the problem statement are: the usage of sensor in one robot are too many. Map generated from laser scanner sensor or 2D based sensor are not accurate at all. And last but not least, 2D type sensors has very limited point of view. Why I say 2D type sensor has very limited point of view? Due to if the obstacle are too high or too low for the 2D type sensor to scan, therefore it cannot detect the obstacle, and it will cause a collision, or it will cause a problem to the mobile robot. So what are the objectives of this project? First, to generate the mapping of indoor environment by using ROS. The second one are to develop a program for navigating the mobile robot in indoor environment, and last but not least, to analyze different scenario of the SLAM path planning. Okay, so what are the expected outcomes of this project? This project will improve the production rate of mobile robot that have less sensor, which are Kinect sensor. This project will allow the robot to run smoothly in avoiding obstacle due to Kinect sensor have a 3D. Due to Kinect sensor can scan objects in 3D. Last but not least, it also create a safer environment for human to coexist with a robot in indoor environment. So the literature review for this project. The literature review for this project is: the Kinect sensor will scan the environment, then it will send data to generate map. From the map, it can navigate mobile robot through the obstacle that has been placed in this project. Okay, so the robot that will be used in this project are Turtlebot. Why Turtlebot? Because Turtlebot is a low-cost personal robot kit with an open source software. Therefore, ROS, robot operating system, can use this robot, or this robot can use robot operating system. And next, there are two types of Turtlebot, which is burger and waffle, burger type and waffle type. Therefore, in this project, we are using burger type Turtlebot. Okay, Microsoft Kinect sensor. Microsoft Kinect sensor is the function of Microsoft Kinect sensor is to build track motion, 3D reconstruction, object tracking, and skeleton tracking application. Okay, for this project, we are using 3D reconstruction. Okay, as we can see here, as we can see from this diagram, there are several kinds of items that we can see, which are video camera, infrared camera, and also infrared projector. Okay, video camera, also called RGBD camera, is a depth sensing device that works in association with RGBD camera that are able to augment the conventional image with depth information. So it's also called RGBD depth sensor. Okay, next is the infrared camera. Infrared camera is a non-contact temperature measurement device that can detect infrared energy emitted, transmitted, or reflected by all materials. And last but not least, infrared projector. Infrared projector including a light source which radiate an infrared ray, and emitter which emits visible light when exposed to infrared light. Okay, mapping. There are 3 types of mapping that will be used in this project, which are head-to-SLAM, auto-map, and G-mapping. For G-mapping is a laser-based SLAM system that uses adaptive resampling to elevate the major disadvantage of existing particle filter algorithm. Head-to-SLAM is a free and open source tools for implementing the proposed 2D SLAM technique. And last but not least, auto-map. Auto-map is also a free open source program that implemented the probabilistic 3D mapping method. So these are the critical review for this literature review. Okay, next are the methodology. Okay, for methodology, we have process flowchart. First, the odometry and scan matching. Next, robot pose, and then predict the robot pose. After that, particle propagation. The particle propagation will be transferred to generate a grid map, and from the grid map we can get a generated automap. And from the automap, the robot can correct its pose, and then it will update the final pose. Therefore, the robot will move according to the final pose. Okay. Next, we have methodology Gantt chart. Okay, from this Gantt chart, we can see that for FYP1 and FYP2, FYP1 occurs during January to June, while FYP2 occurs during June to December. So in FYP1, we have discussing research, preliminary FYP works, and also proposal writing. While in FYP2, we have data collection, data analysis, chapter 4 and 5 writing, report editing, and also final presentation. So the timeline of this project. In FYP2, in 30 July 2021, we will create a simulation design for this project, and then after the simulation design is complete, we will apply the simulation into the tutorboard, and lastly, after the application and also after the application of simulation complete, we will record the data. These are the project schedule. So the simulation design is 4 weeks, simulation application 4 weeks, and data recording is 1 week. Okay. So the project cost. Actually, the project is not very expensive because the tutorboard are provided by the UniKL. Therefore, only item that will be used in this project are Kinect sensor, which are around 280 ringgit Malaysia. The conclusion of this project. Okay, the conclusion of this project are based on the example in mapping the mobile robot. We can conclude that automap has the better map compared to the other two. This conclude that with automap result, we can get a better view of the SLAM path planning, and this allow the localization of the robot to run smoothly. But the only limitation that can occur in this project is the Wi-Fi connection in UniKL between the robot and the PC. Therefore, my suggestion that can be made to increase the to avoid this problem to occur is we can use an Wi-Fi adapter to make the Wi-Fi connection more stronger. So the list of correction that I need to add, actually. So the list of correction for this project one only, that is adding another objective, which I add the objective of to analyze different scenario of the SLAM path planning. And last but not least are the references. Okay, that's all from me. Thank you.